Hello and welcome to our second session of our course. And today we're talking about searching for scientific and technical data to supplement your master's thesis research. Why is it such an important topic? It's because scientists spend up to 50% of their time dedicated to searching for data. So the problem is that there is so much information available online that sifting through it or searching through it can be pretty challenging and time consuming. And you'd think that the cutting edge AI tools would be able to speed up this process, but unfortunately, as you well know, AI tools are prone to hallucinations, and so even though they speed up the search for references, sometimes it takes even longer to check every link, to check every publication to make sure they actually fit your topic. We will try to use those AI tools today and see how good or bad they work, hopefully to help you search for references for your thesis. And it's also important to remember that no scientist works in a vacuum. So it's not like you can just decide to solve some problem and dedicate years to solving it, and only to find out like 5 years later that it has been already resolved like a decade ago. That's why it's so important to conduct literature review. And that's the first and critical component of every research project. And for example, if you choose to do a research master's thesis, so not the classic version with designing a foundry, but a fully research project, a fully scientific research project, in this case, the first chapter of your thesis will be the literature review. And today we'll talk about how to conduct it and how to find and use the sources you find. So, I want you to understand that you cannot just Google something or ask your AI assistant to give you 10 sources on a topic and use the first 5 you find. That's not how it works because not all sources are made the same. There are certain requirements. They must fit to be suitable for research or for scientific projects. First, you should always look for the latest data, so the most recent findings, insights. According to statistics, the data published in books ages about 10% per year. So in a decade or 15 years, the information may no longer be relevant. Of course, that's not applicable to some fundamental knowledge or basics of chemistry, of physics, or something like that. But if it's about the latest, for example, automation techniques or the use of AI in the foundry technology, right? Or about machine learning or using sensors or something like that, this type of data can age pretty fast. And so we should always strive to use the latest sources. But it's not the only requirement, but it is pretty important. Because if you only rely on books or articles published like 30 or 40 or 50 years ago, you may be missing some important discoveries made in the recent years. That's why using the latest publications is always a good idea. But they don't just have to be new, they also must be reliable. And that means, first and foremost, you should know who wrote it. So, who is the author? If you find some web page and it seems to have all the information you need, but you don't know who is responsible for it, you shouldn't use it. The same goes to for Wikipedia, for example, right? Because it's an open source kind of repository of knowledge. And while it can be pretty useful for learning the basics about some concept, we don't know who wrote what, and so we cannot trust it. The same goes for anything AI puts out for you, because uh, likewise, you don't know if you can trust it. That's why it's always preferable to use sources that have specific authors. So, books, um, journal articles, or even news articles, but they should always have authors. So, you know who is responsible for the data you use. Next comes the next important factor in assessing the source's reliability is the publication's reputation. Unfortunately, it's not foolproof, but still you can. Sorry, just a moment. Hello.
Добрий ранок.
Добрий.
У вас лекція?
Ні, в нас практичне заняття
Практичне
англійською.
заняття. Добренько, зрозуміло. Студентів я вас вже бачу. Добре, Ольга Сергіївна, я вам не заважаю. Дякую.
Дякую вам. Гарного дня.
Навзаєм.
So, where were we? Yes, the publication's reputation. So, unfortunately, even the most reputable journals like The Lancet can be mistaken sometimes. So, they may publish the data that's wrong or just not entirely reliable. But still, when we choose articles from peer-reviewed journals or from established publishers, that's always better than when we use like random websites of the web. That's why the reliability is important, and you should always ask yourself, can I trust this source? How do I know that what it says is true? Is it just some generated slop, or is it actually scientific information? It's crucial because, well, in statistics, there's such a saying that if you put in bad data, you get from it bad data. It's a little more crude than that, the saying in its original form, but I hope you understand the idea that if you base your research on bad data, on bad sources, then you won't get anything good out of it. So your research will only be as good as the information you base it on. And our third requirement is that your sources or references should be objective. It's a bit harder to judge if the sources are objective than if they are reliable. But here are a few ideas what you can check out. So there should be no conflict of interest, no corruption, and no biases. So what does it mean for your research? For example, if you are looking for information on coatings or on some sort of equipment or materials, anything like that, and you find a manufacturer selling that type of equipment. How do you think you can trust their claims that their equipment is the best of the best and you cannot find anything better on the market? So would that be an objective opinion or not? What do you think? So manufacturer offers to sell you equipment. Can you trust that their information about their equipment is objective? That was a question to you. Yes, Dennis?
Так.
Sorry, didn't catch it. Can you repeat, please?
Ну, можемо, повірте.
Don't you think they can exaggerate or lie outright about their equipment to make a sale?
Ну, так, можуть, але як це перевірити?
Yes, that's the question we should ask ourselves. So, I'm not saying that you shouldn't trust anything like manufacturers tell you. Of course, if they share some technical specs like the power requirements, the maximum or minimum temperature like a furnace can achieve, the type of materials used. So if it's an objective data, or rather a piece of objective data, you can trust it. But if there are some marketing claims like our furnaces are better than anyone's or something like that, that's not objective because you cannot check it, because you'd have to compare to purchase that equipment from different manufacturers and compare it. That's why we can trust objective data, but not marketing claims. That would be a bias. So, of course, manufacturers would tell you their equipment is the best because they want you to purchase it. Hopefully you understand what I'm saying and that you will be critical with the sources you find, because the more information the world generates, the harder it's to find something worthwhile. And that's why we dedicate a whole session to searching for relevant, reliable, and objective information. So, any questions? I know it's just theoretical for the moment, but I'll show you how to do it in practice in the second part of our session today. So,
Так і нема.
okay, great, thanks. Moving on. So, how does the literature review work? Here's an algorithm. It's pretty basic, but hopefully you'll get the general idea. So first, you choose high quality sources, recent ones, objective ones, and reliable ones. We've gone over that. Next, you should study the sources you find. So first, for example, your goal is to find 5 sources for your literature review. First thing you do is find at least 10 or 15 that meet the 3 requirements we've just covered. So they should be recent, objective, and reliable. So you have like 10 or 15 sources. What do you do next? Next, you must check if they actually, if you can actually use them in your research. That's where fast and slow reading comes in. So first, suppose you have your source. You see that it has been published like 2 years ago. It's in a peer-reviewed journal, and it doesn't seem to have any biases or conflicts of interest. But does it actually match your topic? That's where you should do your fast reading, and we will go over the process in a moment. Once you checked that the source matches your topic, you save it and keep it in a separate folder somewhere on your computer. Once you have your 5 or 10 or 15 sources that that match your topic, that's when you organize the information you find. And after that, you should never forget to include citations. I don't think we'll have a separate session on citations because we've already covered it in other classes, but still, if you need a reminder, there are national standards you should use to cite the sources to avoid plagiarism accusations. Sorry. So, how do you decide if the source actually matches your topic? Most students just look at the title and decide that it's fine because there are some keywords in the title that match your topic. But as we've discussed last time, right, your topic should be pretty narrow. So, for example, not just the qualities or of steel castings, but rather a specific steel grade and, for example, one or two properties and the influence, for example, of heat treatment or using specific alloying elements on these characteristics of your specific steel grade. So it's not just enough to find the name or the word steel in the article title. That's not how it works. So, if you can't rely on the title, what do you do? The most important tool you should use is an abstract. If it's an article, it should have one and it will be available in open access. You can always read the article. It's usually a short passage around maybe 250 words long, and it should have all the information you need to decide if the article matches your topic. Still, you don't always use articles. Maybe you found a book. Books don't generally have abstracts unless they are collections of individual articles, but that's also not always the case. So there is a table of contents, and it should give you a rough idea if the book could work for your project. So, table of the contents or abstracts is what you should always read first to decide if the source matches your topic. Suppose you read them and decided that it's all right and it seems to match your topic. Next, you should look at the conclusions. It's harder for books because they don't always have conclusions, but most usually have conclusions at the end of each chapter. And that's what you should look. So you found the chapter that you're interested in the table of contents. Then you go to this chapter and you read the conclusions to this chapter. All articles definitely have conclusions, and they are sort of similar to the abstract, but abstracts tend to have like a large scale view of the research in the article. So it will have the relevance, it will have methodology, some basic information about the literature review, and also the findings, and maybe also the discussion somewhere there. But the conclusions will have theoretical and practical results achieved throughout the study. And so once again, reading the conclusions will help you decide if the article or a book will work for your project or for your thesis. So, If at any of these steps you find that the article, the book, any other source doesn't match your topic, you discard it and you take up the next one. If at every step your source matches your topic and you think you can use it, you proceed to the next step. So the last thing you should look at during your fast reading process is anything visual in your source. So if it's an article, you should look at tables, you should look at figures, at diagrams, graphs, anything like that. It's because they tend to present information in a condensed form. So a table will have a lot more information than, for example, 10 pages of text. The same goes for diagrams or figures. So authors use them to make their work more understandable to you as a reader. And so you should make the most of these visual aids to understand what the reference is about and whether you can use it in your literature review. So these are the three basic steps: abstract, conclusions, and visual aids. If you've completed all three steps and the source seems perfect, you're in luck. You found your first reference to use in your literature review, and you can check the next one. Once you have 5 or 10 or 15 or however many you need, you can move on to the next step. Any questions?
Немає.
Okay. Then let's move on. So, how does writing a literature review actually work? In my experience, most students struggle with it because they think that it's just a collection of quotes or paraphrased passages from different sources. But that's not the case. A literature review is where you explore and present what is already known about your topic, and you find the smallest gaps or differences or issues that are still unresolved. And that's where you put your focus and that's where you do your study. But first, you need to organize the information you find in your sources. First things, you need to include phenomenon definitions, so basic terms or explanations by different authors. So, for example, if you are dealing with shrinkage defects, you can explore how different authors classify them. So, for example, there can be cavities, there can be porosity, or there can be some gas shrinkage, porosity, or cavities. So you can study the definitions different authors present and look for differences and for similarities. And if you, for example, find that every author in every article, in every book defines these defects the same way, then you can just write it like it is in your literature review, that authors of works number 1, 2, 3, 5, and 10 agree that shrinkage defects are or they come from somewhere. That's phenomenon definition. Next, you can explain or write about phenomenon aspects. So the characteristics of the phenomenon you study. These can be stages, components, characteristics, causes, effects, anything like that. So, for example, if it's gas shrinkage porosity, you can look how different authors describe its origins. So where does it come from? How does it spread in different castings? The effects it has, anything like that. Once again, you look for similarities and differences across different sources. For example, if all 5 sources state the same thing, you write it like that. So everyone from teams 1, 2, 3, 4, 5 agrees that the cause of shrinkage porosity is something. Or if there are any differences, you highlight them. So, for example, authors of works 1 and 2 agree that shrinkage porosity can be beneficial for something, while the authors of works 3, 4, 5 disagree and believe that shrinkage porosity is a major source of casting failure, something like that. So, that's phenomenon aspects. You should, we've already talked about the differences, right? So if there are different opinions on one aspect of your research, that's great. That means that that's where you can explore these differences and offer your own opinion. That's perfect. Most research publications will also include limitations. They are usually present in the discussion section, and most researchers mention them even in the abstract or in the methodology section. What are limitations? They are specific conditions under which their research works, and so it doesn't apply, for example, under other conditions. For instance, so the cause of shrinkage porosity in steels can be one thing, but the cause of shrinkage cavities in cast irons is totally different. So their theories or their findings only apply to steels. So for example, you can study if the same thing works in cast iron or something like that. So limitations are important, and that's where research, different or new research comes from. So if you see that the study is great, but it has some limitations, you can remove those limitations or work around them and add to the scientific knowledge of the whole world. Yes. And the same sections, so discussion and usually the abstract, have discussions about the avenues of future research or potential research. It's often phrased exactly like that. So further research may be needed to study the effects of shrinkage porosity on castings after heat treatment, for example. Once again, that's your opportunity to offer something new to the field of study. So if the authors themselves say that it's a good idea to study this further in this direction, that's what you can do. Of course, if no one else has done this. That's how this works. And so the final product of your literature review should cover the existing knowledge on your topic and lead up to your research question. So what are you going to study? Why is it important? And how you can contribute to your field of study. That's your literature review in a nutshell. That's how it works. Once again, for now, purely theoretical, but we will move on to our practical component in a moment. Any questions?
Значить, немає.
Well, you know that I'll have some questions for you soon, so be ready. Okay, so we've talked a little about where to search for information last time, but just a quick reminder that Google and Wikipedia and YouTube and TikTok are not the best sources of scientific data. Instead, you should use scientific indexes like Google Scholar, Web of Science, or Scopus, individual journals like those that are open access. What you might not have heard about are scientific platforms like ResearchGate or Academia Edu. These are kind of like social media for scientists, and they serve like platforms for exchanging knowledge, for discussions, and everything like that. You might need your university email address to register. But once you do, you can get access to directly to the authors of scientific works. And for example, if you don't find some article in open access and you don't have the funds to purchase it, you can reach out to the authors directly and ask them for a full text article for your thesis. I can't guarantee that everyone will answer you, but most scientists are pretty open to communication, so it's one way to look for credible sources. And other sources, it's the largest category, and it includes white papers, policy reports, industry publications, news articles, and also AI platforms. And we will try to use them today to look for some scientific data as well and decide if it's worth your time. So, before we move on, please tell me if you've used any of these platforms before. So, something like Google Scholar. Yes?
Не, Google Scholar.
Okay, anything else? I'll probably AI, right? Or no?
Ну, так.
Did you use it to look for something scientific?
Ні.
Okay. Well, we'll try today together and see how it works. Because, well, there are some pros and cons, and we'll discuss them today a little later. Okay, so once again, a quick reminder that when you are writing your literature review, or even if your research component of your basic master's thesis, please remember that it shouldn't be 100% someone else's work. Instead, you should pick and choose quotes or data to include and paraphrase, but there should always be something you add to it. And in fact, there should be at least 50 to 70% of something you add to what you find in your sources. If you decide to use direct quotes, it's definitely best if you include quotation marks. So if you copy text directly from the source, include quotation marks. So, and definitely include the number of the source in square brackets. If you're paraphrasing, so you don't copy paste the text directly from the source, you should still have the number of the source in square brackets, but the piece of information you take, right, it won't match the text of the source directly. But it's very important to be careful when paraphrasing, because you it's very easy to miss important information, and it's very easy to include your own subjective opinions or biases when paraphrasing. So always check that you haven't distorted the information from the source when you paraphrase it. So the author's opinion or the author's results should be paraphrased without distortions. Even if you don't agree with the author, or if you have another opinion, or if you want to compare and contrast two information from two different sources, that comes later. So first you include the paraphrased passage or paragraph, and then you include your analysis. Don't mix the two together, because this way you can misrepresent the information by the author, and it opens you up to some unfortunate, potential even legal trouble. So please be careful paraphrasing. That doesn't mean that quoting is better than paraphrasing. It just means that you have to be careful when paraphrasing. So I think we are almost done here. So quick summary of everything we've talked about today. You cannot trust every book or article you find. You should always choose the latest, reliable, and objective sources. If you want to speed up your selection process for the literature review, definitely use the abstract, conclusions, tables, figures, and any other visual aids you find to help you quickly decide if the source is right for your research project. And whether you quote directly or paraphrase anything you take from sources, you should always include a citation. So please get familiar with the national standards and use their rules in your work. So that's it for our theoretical part. Any questions?